Hello, Math 125 fans. On the discussion board, I mean, this is typical. There's always questions about Riemann sums. There's a lot of notation. There's a bit of theory, and it's pattern finding, and so there's always some challenges. And so I thought I would do I'll do a couple short videos, but this one will be in a little more detail. This is a homework question that people are asking about on the discussion board, and it has to do with the notation. But I thought before I did that, I would just do some examples. So we've got this function, y equals x squared plus, and I know people are confused on different things. The functional notation is just a convenient way to refer to the value, which is helpful. And it's between 2 and 4. It doesn't really matter what the picture looks like, but I just wanted to give us a little bit. So we've got this, and we've got this function, whatever it's doing. And we want to know this area. Okay, so we described a process in class. We did an example. We did it with more and more subdivisions. So before I talk about the general process, let's just do two quick examples. This is for those of you that really want to see the steps. So if you do 2 subdivisions, let's start really short. Then step 1 is you compute the width of one of your rectangles. So if you broke this in half, you can see already what it is, but we would like to build a process. So you always do. So step 1, the left endmost point is 2. The right endmost point is 4. That's what A and B is. So B minus A over 2. Let's just double check that this works to maybe help you when you go to do a more general thing. So I'm getting 2 over 2, I'm getting 1. And then I talked about labeling your tick marks. So I said x0, the leftmost tick mark is 2. x1, you get by adding 1 width. And I was trying to explain that process because the width is just 1. This has to be 3. So that goes there. So the reason I'm saying it this way is to help you see the pattern that we're going to use in just a second. So this is going to be 2 plus 1, which is 3. And then the next tick mark will be 2 jumps. You'll add another 1. So it's going to be 2, which was the left-hand point, plus 2 times 1 is 4. So the reason I'm saying that is so you can see that the pattern is B minus A over N. And that in order to get to a certain tick mark, you start at A, and then you add the width, and then times the number of steps. So these are really our only formulas here. And so we're trying to make sense of that, and that's usually where the confusion is. So in this case, what would be the next step? Well, we're going to make 2 rectangles. And let's say we're using right endpoints, just like the problem says. So here's what happens, is you're going to plug in, there's going to be 2 rectangles. It's going to be height times width plus height times width. And some people are just confused because maybe they're forgetting how functions work. If you want the height from here to here, that's exactly what the function gives you. It's this y value. So if you're standing at 3 and you want to know the height, you need to plug a 3 in. I know that's a confusion for some people. So what would this look like? You'd plug in a 3, and then you'd plug in a 4. And that would actually look like this. Let's lay it out. I'm going to write the function here. Square root. Try to stick with me if you're having trouble with this. This is just a little bit of the theory. We just don't want to be completely scared of this notation. Okay, so for this problem, the width of each one is 1, so there's going to be a 1 here. There's going to be a 1 here. And the tick marks we're plugging in are 3, 3, 4, 4. Okay, that would give us one approximation. I have a visual of this. So here it is. It's that. It's the area of the first one. And so if you're confused, some of it has to do with this number. Whatever this number is this height? Right? So if you do that height times that width, it's going to be the area of that rectangle. And this number is the y value or the height that is right here. Okay, so that's what it looks like with two subdivisions. So maybe I'll zoom out a little bit, and let's try it with four subdivisions. Now, to do this problem, you don't need to do any of this, but I want you to see, okay, this is 2. I'm going to pick 4 rather than 3 because I think you get nicer numbers. The goal is to give the process. So let's lay out our formulas. X0. In fact, maybe we can start to think about this. I don't know. So in this case, it would be b minus a, so 4 minus 2 over 4 this time. So it's going to be 2 over 4, or a half, which makes sense. If you break it into fourths, you're going to break it up at those values. The tick marks are going to be a plus I delta x. Now, it's a lot of notation, but a is 2, and then I times a half. And that you can do that. You can do a quick double check to make sure that works. If you plug in 0 for I, you just get 2. If you plug in 1, you get 2.5. If you plug in 2, you get 3. If you plug in 3, you get 3.5. If you plug in 4, you get 4. There's our tick marks. So what would change? Well, what would change is now we're going to have 4 rectangles. And this is the actual homework question is very short. So if you're saying, oh, I'm lost already, it's very short. But this is just talking through. So you now are going to find the height at 2.5 and make a rectangle, the height at 3 and make a rectangle, the height at 3.5 make a rectangle, the height at 4 and make a rectangle. So it's going to look exactly the same as this, except there's going to be 4 of them. Square root 1 plus 2 times this times the width, and then you're going to do it again. Square root 1 plus 2 times this times the width. Then you do it again. There's going to be 4 of them. Square root. The reason we don't do a lot of these examples is because they're kind of big. They're really meant for a computer to do. It's just a lot of small arithmetic. But in this case, the width would be a fourth, a fourth, a fourth, a fourth, and the tick marks would be 2.5, and the next one would be 3, and then 3.5, and 4. So let's kind of take a peek. Let's just grab one of these. We'll circle here. Under this. Look at this. And I'll just grab one of these. Maybe look at this. The question is, what's the pattern? Okay, oh, and I should be, now you're catching me in the video. You're probably yelling at me that this should be a half. I apologize. Just miscopied it. Thank you. Okay, so the question is, what is the pattern? That's really fast to do. You hardly have to even think. But it should include the width, and it should include this with the tick marks plugged in. So when I look at this problem and it says, okay, find the pattern for the Riemann sums, what I say is, well, it's going to look like this. And we even have, we can just blindly follow it, but I wanted to give you a little bit more. This is what it's asking for. And so you can do this in 2 steps really without thinking at all. Limit as n goes to infinity, the sum from I equals 1 to n, and then the function is xi squared plus the square root of 1 plus 2xi done times delta x. And that's the answer, but the question wants you to go a little further and actually say what xi and what delta x are, what the pattern is for them based off of n. And you should know this right here is going to be b minus a over n. But they're not telling you what n is, so instead you're just going to fill in b and a. So it's going to be 4 minus 2 over n, which is just 2 over n. So that's 2 over n, so we're just about there, 2 over n. I'll fill in the rest. The limit then goes to infinity to n. And what's left to do is to replace this thing here with whatever it is. And it's this. So the question is, what is A? A is 2. What is delta x? It's 2 over n. So all you have to do is in these two spots, write 2 plus I times 2 over n. And you're also going to type this in here. I know it's a big, ugly thing, but that's all it is. So your final answer is going to be 2 plus, I probably would write it 2i over n because it's easier to type, squared, plus the square root of 1 plus 2. I know it's big and ugly, but there's just no way around it. Part of the goal of the problem. So that's what you're typing in. But there should be the function, and there should be the width. So this is trying to get you ready for this thing called integral notation we're going to do, and understand a little bit where pieces come from. So that's what the problem is. So what's happening, if I peek at the discussion board, well, I won't show that because I'm afraid I'll show a student's name. But here's 3 subdivisions, here's 4 subdivisions. It doesn't matter how many subdivisions you're doing. Any given one of these, you're just taking this tick mark, plugging into the function, and multiplying times the width. And the rest of it is just, can we give a pattern for the width and the tick marks? Okay, hope that helps for those of you struggling with the notation or that problem.